Okay, so at the bottom of this page 32 in your workbook, we're going to take a quick look at the notes here. Obtaining the slope of a line from its graph. The slope of a line is the measure of the line's steepness. We denote it with m because when mathematicians began working with slope, it was called the modular slope. As the absolute value of m increases, the line becomes steeper. As the absolute value of m decreases, the line becomes flatter. So that's why when we have fractions that are between 0 and 1, we're going to have more, they're just more spread out on the run part. A line that rises left to right has a positive slope, and a line that falls left to right has a negative slope. So you're going like uphill versus downhill. M is the change of y divided by the change of x. So these symbols here, this little triangle, that means delta y, or change in y over change in x. So it's always the vertical change over your horizontal change. You may have heard that as rise over run. Another term that we use a lot is called average rate of change. For linear functions that we're working with, right now, it's fine. We don't need to worry about it because we don't have any curves, and it's a constant change or consistent change. But you may hear this later at Rock in math. You guys will probably be taking Math 99 next. So I just want to look back at this graph we have here. If we look at the steepness to get from one point to another, we start at the y-intercept, and if we go up a rise of 1 unit and over 1 unit, then our slope equals 1 over 1, and we simplify to 1. So that's, not too steep, but if we had something like a bigger number, like 1,000, that's going to be really steep. 1,000 over 1. This one from before, we have a rise of 1. If we look at this little slope triangle here, to get from one corner to the next, I would go up 1 and then right 4. So that is a slope of rise 1 over run 4. Okay, so 1/4. And you can see that right here. We write it as y equals mx plus b. This classwork that you guys did down here, x minus y equals -3, let's just quick look back at that for part C. That is written in standard form or general form. And we could actually rearrange that. We could write it as negative y equals -x minus 3, or y equals x plus 3 if we divided through, or actually multiplied and distributed by -1, we could think of it as, and do a literal equation solving for y equals all the other stuff. So that's going to be a pretty popular thing to do. Then we would see here, if I put 0 in for x, I get my y-intercept right there. My slope is 1 over 1, so up 1 over 1. And we can actually graph that way, plotting points in like a staircase. We wouldn't actually write in the triangle things, but just to show you how that's kind of like the staircase, and the steepness of the step is our slope. And these are both positive slopes because we read left to right. So let's look at the next page and see if you can look at a graph and figure out how to find the slope. So there's different ways to find slope, and one is by looking at the graph, just like I did here. Another way is by looking at the equation. Okay, it's the coefficient of the x when it's in slope-intercept form, y equals mx plus b. And the other way is by formula. We can actually calculate out, given 2 points, we can find the difference in the y's and divide that by the difference in the x's and find our slope. So now we're on page 34 of your workbook, and we have these two examples. We have find the slope from the graph given the line. So this one on the left, this increases from left to right. So first thing I want to note down is that this is a positive slope. Okay, so we're going to just jot that down. The other thing we want to take a look at is let's pick a couple of key points. So we pick the y-intercept falls right on a grid line, and then let's try to pick something else that falls exactly on a grid line so it's easy for us to tell by looking at the graph. So that's not always going to help, so sometimes we definitely need to use the formula. But if I start here and I go up 1, 2, 3 units, so this would be up 3, so it's a rise. But sometimes it could be a fall, but that one's a rise, the way I'm doing it, kind of left to right. Up 3, and then I have a run of 2. So my x is a run of +2. If I go right, it's positive. So remember that my slope is the change in y. This is my change in y here, over my change in x. And this is my change in x is the 2. So I'm going to write that as m equals 3 divided by 2. I know it's positive. That's why I track that to make sure all my signs are in check. I didn't do anything wacky with that. And then I would reduce it, leave it as a reduced improper fraction. We don't usually put it as mixed number or decimal. One thing I want to point out too is that we could actually do the exact opposite thing. We could start at that 0.01 again, and we could go down. Where's my corner on this one? That's a little trickier for me to see right here. Okay, we could go down 3 units, 1, 2, 3, right? And that would be a fall. So that's fall -3. And then we would go left, 1, 2, -2. So a run of -2. And that would give us delta y would be -3 over -2, which actually is the same. It equals 3 over 2. So we have the same exact thing. Once we reduce and simplify whatever we're doing there, this one we're just simplifying by making 2 negatives be a positive, we would have the same slope. Another way to find slope, which we'll go into in the next section, but I just want to show you right here on this graph too, because you've probably seen this. I'm sure you've seen these things before. If we have the points, so let's pick a point here. We have 0, 1, and we'll call that point 1. And point 2 we'll call 2, 4. Okay, so we can also do it as this formula. If it's the change in y over the change in x, we can take the second y, subtract the first y. Generally, we just label left to right, but you could actually switch those as long as you do the same with the x's. Second x minus the first x. And if I plug in those points, I would get the 4 minus 1, all divided by my x values here, 2 minus 0. And lo and behold, I get 3/2. So I get the same answer no matter how I cut it, right? As long as I'm simplifying. And I could also figure out the equation of the line from that, but we'll get into that later. So pause the video, see if you can find the slope just by one method, just by looking at the graph. So classwork, find slope. And tell me if it's negative or positive, would be helpful also. There's another couple of problems down here too. You might be looking at those. Oh, that's kind of weird. How do I figure that out? Well, think about it and try, but I'll go over those too. Okay, so for this classwork, we have a negative slope because y is decreasing from left to right, where here, positive slope, y is increasing left to right. If we look at the slope, we have 2 points on the corners, down 2 units. So my change in y is -2. Right 4 units, my change in x is 4. Then I reduce it to -1/2. So I want to attach that negative to either the top or the bottom or center it. I wouldn't do both. What I might have done instead, though, I could have had something like, let's pick red. If I went up, I could have had a +2 and a -4. So my slope would have been 2 over -4. Well, it's still the same slope because I'm going to reduce and I get -1/2. Now, if we have just a horizontal line, what's happening with that? Let's just pick a couple points and take a look. So if we have the point -1, 1, and 1, 1, and we try to go from one point to another, there's no rise. So our m, remember, is change in y over change in x. So if I have no change in y, we write that as 0. And then my change in x, I mean, it's really infinite, but we'll just say, oh, okay, for this particular pair that I picked, it's over 2. So that would be 0. 0 in the numerator is 0. So slope is 0. So the slope of a horizontal line is always 0. And that's somewhere in your notes, I think, here on the next part, maybe. Yeah, on the next page, you'll see that. Now, this goes with this line here. So vertical lines, remember, slope is change in y over change in x. Now, we have a certain situation here. If I pick a couple of points, just pick -2, 0, and let's pick 3, or actually -2, 3. I have 1, 2, 3 for my rise, right? But there's no wiggle room happening. There's 0 horizontal change. So whenever I have 0 in a denominator, that is undefined. So I'm going to say m equals undefined. Always write that, or you could write DNE for does not exist. Okay, I think that's what you're writing a lot of times in your curriculum, that you have your My Open Math. So vertical lines will always have an undefined slope because, you know, it's just here. And if I were to write the equation of this line, it would be x equals -2 because x is -2 here, there, everywhere, actually along this whole line to infinity. Where this horizontal line is the y's that are always going to be 1. So that would be my equation. We'll do more with that later, but just so you have that seed planted, hopefully you've kind of experienced that. But this is usually a stickler for people, so make sure you commit this to memory, write it down on a card. Even though you're taking your tests at home and stuff like that, you'll want to have something handy to make sure that you don't just inadvertently mix those up. It's really easy to do. So that's it for this video. Then we'll look at the last page is the formula, and that'll be it for section 3.1.